All right. Hello, ladies and gentlemen. Let's run through some notes. So I'm gonna try to go as fast as I can, but you're gonna find these two are gonna also be pretty long notes. Because I'm gonna try something new, which is to integrate some of the homework I gave you into the notes to give you a sense how you could be doing that too. So you guys know that I'm not collecting the homework for points, which means that it's really just for your practice. So at some point, those practices should end up in your notes. Otherwise, why would I be given to you, right? So this first part's going to be repetitive, but you guys know kind of what's going on here. Also keep in mind that if you find I'm going too fast or say like, whoa, I just moved that and I was writing that down, remember you're watching a video, so you can totally still back that up, pause it, so you can get everything that's on the screen into your notes if that's your thing. Okay, so let's talk about the basic notations for basic geometric constructors. We're going to start with a point. We know that this is just really point A, and with a little note here that you can name it anything that you want. Okay, there's nothing special about that. It is simply just point A in this case, or point alpha, or point Albert, or point anything that you possibly want. Moving on to a line, and this is really, people are viewing this as benign, as something like it's really simple, but this is actually really, really important point of the geometric study, because if you can define these geometric constructors really well, then you can actually define pretty much anything really, really well. So in terms of what we're doing, DC is going to be our line. And really just like picking 2 points, naming them with the proper convention that you saw before, and then representing that with a line. Now, that's not how a line is formed, of course. You have to pick all the collinear points that are collinear to D and C, and that's how a line is formed. But you get the point we're just going to actually be representing here. So in terms of notation, we have DC with a line symbol over DC, and that's what we have for that notation. Segment is like cutting off both ends, so using the same type of lettering system we had before. We just have a representation of all the collinear points just between the 2 points this time. And so we're going to shorten our notation on that side as well. For ray, it's like we're cutting off all the points collinear just on one side. And so let's say that was D, that was C, so certainly DC will suffice. Or if you want to be weird, you can reverse the letters, but then you also have to reverse the ray, because unlike a line and a line segment, the order here does matter because it is directional. Lines aren't directional. They go in both directions towards infinity, all the collinear points in both directions. Line segments are non-directional because it's all the points that go in between 2 points, but rays are different because it has a definite starting point and then it has an orientation point, which may be new, maybe new, no, sorry, vocabulary to you. So that might be worth writing down too if you didn't quite catch what I said. This is what I'm going to call the starting point, and this is what I'm going to call the orientation point. Because D tells you where to start, C tells you where to go, and that's really the case with any line or one-dimensional figure. That's why you actually need 2 points, because you need a place to kind of tell you where to start the representation, and another point to tell you where to continue the representation. Now, in terms of plane, and this was much to the chagrin of a lot of people on the last quiz, but a plane does indeed need 3 points. With the first 2 points, you're just establishing a line that's going to be part of the plane. We'll go a different color here. Shout out to Oakland here. So with the first 2 points, you're just kind of establishing a line that exists within the plane. With the third point, you're then giving the plane some two-dimensional definition. Now, of course, if you actually want to define the whole plane, you guys take it a step farther and define more lines, which is really what the quiz question was asking. But in terms of just naming here for our notes, if we just have the 3 points, that's going to tell you your plane. So just like A, B, C, or any combination thereof will suffice. Now, not every class got this note, so here's a chance for you guys to get this note. An angle is kind of formed the same way. You want to first pick 3 points, and then between those 3 points, define some line constructors. So if we have these 3 points defined, let's just call them ABC. We'll name this angle ABC, which is how you can distinguish it from talking about the plane. We got the nice little angle symbol there. Now this should be purely review, but in case it's not, let's talk about parallel. So parallel is a case where you have two lines that are equidistant apart, and let's call this, like, I don't know, AB, and call this one DC. So we can definitely say that we have line AB and line DC, and the symbol we're going to use to show parallel is that. That means parallel. Perpendicular, again, hopefully this is review. If not, here's something new for you. We need a couple line constructors. It doesn't really matter what they are, so I'm going to make this one just a ray. Then I'll make this one a line. So again, if we have, say, like line AB and then ray CD, we have AB line, we have CD ray, and then we could say they are perpendicular, which that's a perpendicular symbol. So language of geometry is important because, like, you need to be able to talk about things well and also understand things that are being told to you very well. And notation definitely helps us do that. So I picked out some examples from your homework, excuse me, from your practice, I should say. And although I'm not going to answer the questions that are actually on there, I just want to run through and just talk about a few of the parts, and maybe we'll get a sense of it. So, like, what I'd really like to do is just go through and name a few things, and I'll try to color code at the same time. So if I'm talking about this structure, like right here, and I want to know what that structure is named, notice that I have a point in the middle, and then I kind of extend in two directions. I'm not trying to bother to define in between B and T, so in this particular case, I'm talking about an angle. So we have angle B and T. If I'm talking about, say, picking just 3 points, oh, what's going on there? Oops. Okay, so picking just like 3 points, let's say, like, oh man, let's say S, let's say O, and let's say P. Those are three non-collinear points. So if I think about those three like together, I'm really talking about plane SOP. Uh, let's say I'm talking about O and N. Not quite sure why it's doing that. N and then O together, and let's throw in T there for good measure. If I'm talking about all three of those together, saying like with this configuration, then definitely I'm talking about line segment ON. Notice even though I had 3 points that were collinear, in standard actually just use 2 points. So just keep that in mind. That even though you might have 3 points that all could apply, only 2 are actually going to apply in this case. Right. So what else we can do? So let's say we're talking about this guy right here. We're definitely talking about a plane. So all we really have to do is pick out 3 points on that plane. So I'm going to pick out B, N, and T. And that would be the plane. And so you can see this whole naming system is really just for identifying things. Here is a question that was really just from your quiz. It's renamed, of course. But I just want to point some quick things out. Like if I pick out, let's say, this line segment, and let's call line segment AB. If I want some things that are coplanar to AB, I actually have a lot of choices. Any of these would be coplanar to AB. So an answer could be, let's say, AD, DC, and BC. But we have, like I said, we have some other choices. Actually, anything up here would work as well. So also coplanar to AB would be AE, line segment, of course, EF, and FB. So it's important to know that these sets are all coplanar to AB, but the orange and purple sets are not coplanar to each other. And again, you're kind of getting a sense of like why this notation hopefully is put into place. Like it really has a lot to do just being able to identify things well while you're talking about them. So like if I wanted lines that if I just like tell you I want lines that are coplanar to AB, and you don't recognize that AB in this particular case, is written as a line segment, you're not going to know where to look. Like so, if you're not familiar with notation, you're not going to be able to actually answer any question geometrically speaking, because you won't have a clear sense of like what I'm referring to. So how are you going to know what to pick out? Here's a couple examples of like how that could play out. So let's say I wanted to sketch a single diagram, and that's what this question is actually getting at, a single diagram that has all these characteristics at the same time. Well, if you don't know the individual notation, you can't even answer this question. That's going down to 0 because you can't even start. But if you did know the notation, this question is actually pretty easy. So if you note, please, that all this should be in a single diagram, and also there's could be a few variations that are possible. So what you're going to see is just one of the many variations that would be possible. But anyway, let's get into it. I'll try to color code as well. So this first step I'll draw in purple. Well, notice AB is a segment, so I can draw that. A segment is just all the points collinear to two given points. And I need to draw a parallel, and I'm sorry I zoomed in so much, but that looks like a parallel line at CD. So I'm looking right here right now. So parallel line CD, so I'll do that. So I need C, I need D, and it's got to be drawn parallel to AB. So that looks pretty good. There is a mark. We haven't really talked about marking diagrams because we haven't done too much of it. But if I want to show things are parallel, chevrons are natural here. These little chevrons, I'm going to make them in a different color. These chevrons in pairs, one chevron, one chevron. Chevron is a fancy way to say arrowhead. Since there's one chevron each, those lines can be assumed to be parallel. We're sketching here. We're not doing a precision drawing, so this is good enough. Let's see, E exists on CD. Well, again, notation-wise, if you just see a letter by itself, E is just going to be a point on CD. So I got to draw it on the bottom parallel. And then you have this business. And so, again, notation-wise, if you see EC like this without a symbol, that's a distance. And so ED is a distance too. So E has to be on the line below. And so the distance EC is equal to the distance ED. Now that sounds super complicated. That just means I got to put it in the middle. That's the only way I can make two distances the same, and that's usually marked with a vertical tick mark. So I pick point E right in the middle. So the distance CE, boom, is equal to the distance ED, boom. One last step. Let's do this one in a warm color, pink. Okay. F, again, now we're talking a point. F exists on AB, so we got to draw on the upper segment because that's what it says here. So that EF is perpendicular to AB. So F has to be drawn in such a way that when I construct this ray, EF, it goes from E through F and is perpendicular to AB, which I'll mark with a symbol. So again, this gives you hopefully a demonstration of like how if you don't know your notation pretty cold, you're going to really struggle with this type of question. Now, this question's coming, so like this is a preparation. This is like a fair warning. Learn it now so later you won't struggle too bad. We can do another one really quick. Again, let's color code. So the first one says ABC exists. Now it doesn't tell me how to make ABC, so I'm just going to kind of plot out where A, B, and C should go. B is definitely in the middle. It's a vertex. It's right here. I don't know what kind of lines to make this, so that's going to be good for my first part of the drawing. Let's go ahead and read this one. We have point D that's collinear to BC. Now here's where you get a clue. So BC should actually be a ray. So I'll draw that in right now. Ooh, look at that awful straight line I just drew. And then D is collinear to BC. So if D is collinear to BC, that means D has to be somewhere on this line. Otherwise, it wouldn't be collinear. Now, it doesn't say it has to actually be on the ray that's composed. It has to be collinear. So if I wanted to, I could totally make D here, or I could make D here, or I could make D here. I just had to pick one because all those would still be in the same line as the ray. The most common one is probably going to be on the ray, like that's kind of the normal kind of stand on how these directions are given, but you can choose to put it anywhere on D, whether or not it's actually on the defined ray. Last bit, we have FD parallel to AB. Now, AB is finally named. It's also going to be a ray, so I'll go ahead and draw that guy in. I know it's going to be a ray because of that symbol right there. And then I have to add a point F so that DF, which is a segment, is going to be parallel. So that means F is going to have to be somewhere like right here, or it could be over here. It doesn't really matter because the point is when I draw in that segment, it's going to be parallel. So again, the more common one is going to probably be in the interior space of the angle. So I'll draw it. And the note, it wants me to do a segment, so I can't extend it. It's parallel, so I'll show parallel. And there you go, Bob's your uncle. So again, you can kind of see how quickly complicated this can get. And you definitely need to know your stuff to be able to produce those last two drawings, which is going to take a lot of sight recognition. So this is one of those things where it's practice, practice, practice till you get it good. And I'll provide some more practice for you later. This is more just like a dipping your toe in the water about what's coming next. So here's the last part. If you want some bonus points, here's how you can get them. Now that you've taken all these notes, the next thing you need to do is write a summary. So I'm going to incentivize that. So what I want you to do is use the summary process outlined below, highlight 3 to 5 words or phrases that are needed to answer the essential question, write a summary in just a few sentences in this area. But if you post your summary as a reply to this video, I will give you bonus points on the unit test coming up. You can choose to use those points, I guess, in one of the quizzes, but the quizzes aren't worth as much, honestly. So I would actually just put it into your unit test. That's kind of my default mode. So that part's optional, but you earn some bonus for doing it, and you can help some classmates out too, so they can read your summary just in case they miss something. But guys, that's it. Thank you for persisting through the notes. Tell some friends who who are not doing this in note process, but might be struggling a little bit. Tell them to get on the ball and start doing it. Right. Well, you guys have a good rest of your weekend or week, depending on when you watch this and take your notes. I'll see you guys later.